All right, so this problem deals with the idea of impulse, and it reads, a bullet is accelerated down the barrel of a gun by hot gases produced in the combustion of the gunpowder. What is the average force exerted on a 30 gram, so 0.03 kilogram bullet to accelerate it to a speed of 600 meters per second in a time of 2 milliseconds, so 2 times 10 to the minus 3 seconds. All right, so we want to remember a couple things about impulse. Impulse is that relationship to Newton's second law in terms of momentum. So we want to remember that impulse is equal to our change in momentum. That, of course, as with any change, is our final momentum minus our initial momentum. And to get that change in momentum, we have to apply a force, an average force, during a certain amount of time. So impulse is also can be related to both the force causing that change in momentum on average times the time that force is acting. So we're going to use both of these relationships to solve for my average force. If I combine these two equations, we find that the average force times the time is going to equal my change in momentum. And since I want that average force, that's my change in momentum divided by my time, which is my final momentum minus my initial momentum divided by that time. Now let's look at this problem. It says it's accelerating it down the barrel of that gun, which means it starts out at 0 speed, 0 velocity, and therefore the initial momentum is going to be 0. And so I'm left with my final momentum divided by my time, which is my mass of that bullet times the final velocity divided by the time. So that mass of the bullet is 0.03 kilograms times the velocity of the bullet at the end of the barrel. It says it gets to 600 meters per second, and it does that in 2 milliseconds. So 2 times 10 to the minus 3 seconds. And when I use that, we find an average force of 9,000 newtons. So using that impulse relationship, recognizing the two ways we describe impulse mathematically, and then using that idea to solve for the average force on that bullet. Good job.